The broadcast is now starting. All attendees are in listen-only mode.
Good morning and thank you for joining our ANSYS Release 17 CFD Update seminar. Over the next 30 minutes or so, we will focus on some of the most popular and commonly used enhancements within the CFD R17 product range. My name is Brian Miller and I'm pleased to be joined by my colleague Chris Bennett, who is involved in our CFD team. There will be a question and answer session at the end of today's presentation, and you can easily submit your questions via a panel within your GoToMeeting window. For any of you who are not familiar with wired analysis, we've been involved with ANSYS as a channel partner for 16 years, providing a combination of software, training and consulting services. We have a large experienced technical support team based of CFD and FEA engineers, and we're able to provide both standard and customized training both at our offices and on site to help you get the very most out of your ANSYS software for both FEA and CFD. I will now hand you over to Chris, who uses ANSYS CFD daily, to give you an overview of the new features within ANSYS.
Good morning. We'll just start off with a quick overview of what we're going to be talking about. We're going to discuss a few points to do with FLUENT and CFX, and we're going to cover some of the extra tools which in Workbench which have an impact on CFD modeling. We'll just start off by saying that FLUENT and CFX will both be retained in the future and continue to be developed as far into the future as we can know about. CFX perhaps with more emphasis on turbo machinery, with FLUENT as the flagship. There's also new CFD tools coming in. Forte for engine combustions is coming to the ANSYS stable, but we will not be covering that today. It's also worth at this point mentioning ACT, customization. The customization toolkit. It's not something that's new, but it's technology that is developing fast and becoming much more mainstream within Workbench. And as I said, we'll also discuss a couple of changes with some of the extra tools. Right, FLUENT. The most visual changes at the moment is that there's an interface. Other changes include data output to Workbench. There's more options for monitoring solutions and even visualization within Workbench rather than actually through the FLUENT interface. It's faster, particularly with high performance computing, but with a number of other enhancements as well, which we'll touch on briefly. And there are a number of enhancements. These include the warp phase gradient correction method, which is a way of dealing with poor meshes. There's enhancements to the adjunct solver, which we'll also briefly discuss. Overset meshes and new turbulence models. And there's a number of other things which we will mention briefly as we go on. FLUENT interface. The big change that's come in version 17 is the ribbon bar at the top of the worksheet, the top of the window. This is to give you more a feel of the workflow. This replaces the drop-down menus I had before. The tree on the left-hand side was present in version 16. But the big change is in the ribbon at the top. This is hopefully going to make it much easier for new users and for infrequent users. Solution monitoring. There are new options for solution monitoring in Workbench. Primarily this means that you can actually monitor solution progress within Workbench rather than going back into FLUENT to do so. This has some particular advantages when it comes to areas such as parametric optimization, when you potentially going to be carrying out a large number of runs and you don't necessarily want to go back into the FLUENT. It's a way of actually seeing what's going on in perhaps a more friendly way. Part of this new capability also enables you to pick up contour plots from within FLUENT and display them in the Workbench. Again, particularly for parametric runs, this will be very useful because it can give you a very quick visual indication of whether the solution is behaving itself or not. The pictures themselves are only actually updated at the end of each run, but then if you're doing a large number of runs, this may be a very useful feature. You can also you can also see the transcripts in the new solution interface as well. FLUENT running faster. There's a number of high-performance computing enhancements, including faster partitioning, model-weighted partitioning. This is a new feature where it looks at the physics that's actually being carried out, especially in different areas of the model, if there's multi-physics, and will partition the solution accordingly. It's not just going to be on the mesh distribution. This may well have some major, may lead to some major increases in speed for the right sort of cases. Enhancements to interface communication, particularly high performance computing again, and improved robustness, and an emphasis on dealing with particular problems, including moving dynamic meshes. And the picture we've got here is from the ANSYS literature covering a crank-based lubrication model, and there are some major improvements in speed. They've also got some new options for looking at convergence. There's a conservative coarsening technique, which has changed perhaps the emphasis a little bit on where the solution goes, but has some major advantages in improving convergence, particularly on polyhedral meshes and using the pressure-based coupled solver. Warp phase gradient correction. This is just a correction for the particular schemes. The pictures below show in detail an area of a damaged mesh, poor mesh, and the typical solution that you would get without using the technique on the left-hand side, which is very poor and dominated by those poor mesh cells. In the middle of the picture shows the mesh with it shows the solution on the poor mesh with the new model, and then there's a comparison on the right-hand side. There's a good quality mesh solution, and there's certainly some major improvements there. Adjoint solver. We will talk about the updates to adjoint solver in a second, but it's probably worth at this point actually introducing it to those who don't actually know of it or come across it before. It's a specialized tool that extends the scope of analysis. What it's typically for is for topological optimization. That's what its main use has been, certainly as far as we've been concerned. What it does is it iterates over a number of CFD models, and it looks effectively at the changes that given parameters have on a solution and uses a sort of slope model of derivatives to actually guide the design modifications. Oops. Oh, okay, that's right. Oh, I see what's going on. Sorry. This is a particular workflow. Actually, typically, we're running from CFD analysis. CFD analysis produces a set of results. It looks for changes in those results based on changes on parameters you set up in the analysis. It uses that to post-process some results, look for potentially for local optimums, and it'll walk potentially towards an optimum candidate. This is different from the sort of optimization that takes place in Design Explorer. This is an example, sorry, the updates to the adjoint solver, which are potentially making it increasingly useful. It now supports compressible. The most useful thing of all is now it actually supports the output of SCL mesh files, which allows you to take modified mesh, modified topology, and bring it out and put it into the geometry modification tools such as SpaceFlame. And there's also the ability to set up bounding boxes or surfaces, including SCL surfaces, to define the areas where the topology is allowed to go. In this particular example, it's a pipe potentially underneath the dashboard where it's limited areas where it's going, and the aim is to modify its shape. So first of all, it actually fits within those bounding boxes, and secondly, to reduce pressure drop across the actual system itself. And as you can see, that the solution moves and parts of the tube flatten and change the shape. Another new feature that's coming in version 17 is the ability to use overset meshes. The example here is of a couple of gears rotating, but typical other applications of overset meshes include ordnance dropping from aircraft. It basically means it allows to have different meshes around different components, and within FLUENT it will actually interpolate results between meshes and handle the communication. This is another way of potentially dealing with very awkward meshing situations. At the moment, it's available for 3D and 2D planar simulations, steady and transient. It's available for pressure-based coupled solver, incompressible density method, single phase or BOF multi-phase, heat transfer. And there's limited capabilities with turbulence at the moment, but the SSTK Omega model certainly is the one that we generally use. So it's in the main tools. There is, as seen in every update, some new turbulence models. In version 17, there's a shield-attached eddy simulation and a stress-bladed eddy simulation. These two new turbulence models are available in both FLUENT and CFX in version 17. Other FLUENT changes, which we won't discuss in detail, but we'll just touch on. There's been various enhancements to the discrete particle model, including better particle tracking and new boundary conditions, including rough walls. There's enhancements to the open channel flow. There's been considerable movement on doing chemical reactions. Chemkin as a module was available under an additional license in previous versions, and it's now available without an extra license. There's a new macro particle model, which basically allows you to look at the impact of particles which are of the similar size scale to the mesh size or larger than the mesh size. There's been updates to the reporting system within FLUENT, and there's also been enhancements to FLUENT meshing, including the ability to create native polyhedral meshes rather than just relying on conversion from text to polyhedrals. CFX. As with FLUENT, there's improved parallel performance. The quoted figure is 20% faster since version 16. There is an increased focus on turbo machinery, especially transient rotostatic cases. Enhanced multi-physics robustness. Enhanced multi-color radiation model, including improved scalability with high performance computing and extended boundary conditions. New turbulence models, as in FLUENT, as in the previous slide. Enhanced fluid structure interaction, and you're also now able to pick up monitor plots in post, in CFD post. Very briefly, turbo machine faster transient blade row modeling. Features include multi-stage time transformation, conjugate heat transfer. These are all things which are considerably faster with the latest changes. Fluid structure interaction is worth mentioning. Previously, CFX used what was called the MFX connection method, which is a direct connection between CFX and mechanical. It now uses the same system effectively as FLUENT, where everything goes through a system coupling box. This should make the workflow considerably easier. Moving away directly from the CFD models onto some of the other tools which have an impact on CFD modeling. There have been quite a number of changes within SpacePlane Direct Modeler, which is the geometry modeling tool of choice within ANSYS. A couple which are of particular interest from the point of the CFD. One is the shrink rack modeling, as demonstrated with the images shown here, which is a a great way of cleaning up very poor very poor CAD quality, or effectively you're putting a new surface sort of directly over the old and working with that rather than the original surface. And also is the enhanced ability with dealing with STL meshes. This has some particular applications in that it is, well, for instance, with the adjoint solver, you can extract STL meshes from the simulation and bring it directly into your CAD modeling, and also potentially other surfaces, say bubble surfaces, or any particular features you want to bring out, you can then potentially take and look at through the CAD as well. Within CFD Post, one feature which is part of FLUENT and CFX, which is being exploited in the Post, is the ability to, instead of outputting data for the whole of the model, is actually to output data potentially over just a small surface or section. It's an arbitrary surface that you can set up anywhere, and this has some major benefits when it comes to transient modeling, in that instead of outputting full data sets every 50 times or something over the course of simulation and using a huge amounts of disk space, you're potentially only outputting a very small amount of information alongside the major files. But basically it's a way of actually getting a lot of just the specific information you're interested in, and it means much faster processing and much faster visualization of transient data. Another feature that's coming into CFD Post is the ability to, again, import STL meshes and also to render them. This potentially improves the context of results. In the picture here, there's a rendered butterfly bar. You're also able to export STL files. As stated before, you can bring those straight into SpaceFrame and be able to use those for further geometry modifications. There's also an updated music player style animation tool within Post. Much of the functionality is the same as it was before, but there's perhaps a little bit more ability to actually go forwards and backwards within an animation. And it's also worth mentioning or finishing with ACT, the application customization toolkit, workbench-based, allows the development of bespoke solution templates and workflows at a schematic level and within applications. Typically, it's a sort of tool that you may well use to effectively automatically set up workflows for problems, for say repetitive problems typically, also for standard meshing approaches. It also enables the integration of third-party applications, and it's based on Iron Python scripting. There is now available through the ANSYS customer portal an application store which offers free and paid-for applications. At this point, it's probably also worth mentioning, finally, Design Explorer. There are a number of enhancements with that. The ones which are worth mentioning at this point is some increased usability as far as response surfaces goes. First of all, there's a new algorithm which is called genetic aggregation, which basically is a more intelligent sort of cure-all for what's the right sort of response surface to use, and potentially, more importantly, a new file format for outputting response surfaces to both the reader, which is available through ANSYS, or as to an add-in on Excel. And then a lot of this is all driven by ACT as well. Right, in summary, as ever, there's reduced simulation times. There's a lot of emphasis on faster pre-processing, on the push towards making ANSYS 17 easy to use to create well-validated results. So there's a lot of updating to, well, certainly FLUENT interface and to some of the interfaces within Workbench. Improved system integration through ACT, giving better workflows. And there's new models increasing the range of physics that can be simulated.
Okay, Chris. Well, thank you very much. Just before we move on to the question and answer session, I would just like to remind you of another webinar that we are running today at 2 p.m. this afternoon, which focuses on the ANSYS AIM product. Now, this is a relatively new solution from ANSYS. Built upon ANSYS Workbench. It actually uses a very streamlined user interface and is very much wizard-driven. It can run FEA, CFD, and some electromagnetic simulations, so it is a multi-physics package. And it's been particularly targeted for both design engineers who use simulation occasionally, and also analysts who maybe with some of their activities have regular simulations to run where AIM can potentially offer some efficiency gains. In addition to being a standalone package, AIM actually is integrated within the mechanical CFD bundle. So if any of you attending today do have the mechanical CFD bundle from ANSYS, then you already have access to the AIM solution. So to find out more, we welcome your attendance this afternoon. To register, just simply visit our website or just drop us an email or phone call and we'll make sure we reserve a place for you. I'd also just like to point out some forthcoming training courses. As I mentioned at the start, more and more our training these days is customized around clients' individual requirements. And we'll be delighted to do that with any of your CFD training requirements. But we do run standard courses as well, and some of the forthcoming ones include a day on ANSYS Design Explorer. Chris mentioned that earlier as a design experiment optimization tool. So that would be obviously of interest to be run on the 20th of April. In May we are having refresher training on CFD meshing, and we're also introducing ANSYS FLUENT for any of yourselves or your colleagues who are perhaps new to this solver. And as Chris mentioned, we use Space Claim Direct Modeler more and more for our geometry pre-processing for CFD problems. It's very intuitive, so in many ways training isn't necessarily required. However, for completeness, we are running a one-day session in early June, which again, you're very welcome to attend. Okay, so now I'd just like to move on to see if we have any questions. Okay. Well, a couple have come through. Actually mentioning the Space Claim product, I currently use Design Modeler. Is there a good reason to use Space Claim for CFD, Chris?
Yes, well, certainly we've been using Space Claim for a couple of years here now, and certainly we have both tools available, and most of the time we end up using Space Claim now because it's a very, very easy and fast tool to use for a lot of the geometry work we work with.
Okay. I would just say actually what we tend to find with a lot of our customers is some of it's down to personal preference. We typically offer an evaluation license of Space Claim just for you to try it and see how you get on with it and see whether you prefer it to using Design Modeler or your current CAD system.
Yeah, I think it's just worth adding that it really is something that you have to use to actually understand why it's different and why it's better to use. It's quite hard always to describe, but it's certainly easy to pick up. And also, actually, I think when you're talking about training, I mean, it's very easy to pick up a lot of the very basic functionality, but there is a lot of tools within Space Claim, which I think the training does help to bring out.
Okay. Okay, and we have a second question talking about the joint solver. Is it useful for applications other than maybe pipes in the examples you've shown?
Yes, well, certainly it's used quite a lot for external aerodynamics, things like fairings, typically shapes of leading edges of, say, buses or wing mirrors. There's there's quite a number of applications, I think, yeah, overall.
Okay. Okay, well, I think that concludes today's session. If you have any more questions, then please feel free to contact us offline using the contact details on the screen. I thank you for your time. I hope it's been of use, and we look forward to hearing from you soon. Thank you.